Well, hi, good morning from the shores of Lake Couchiching, just above the big Lake Simcoe, in amongst the Great Lakes in Ontario. That's where I'm located. Now, if you're viewing my videos for the first time, let me just put out a little bit of a warning here. This is essentially a live video. I don't prepare for these in any kind of serious way. So I just wing it and go along. Consequently, sometimes I don't know what I'm talking about. Maybe a lot of the time, I don't know. Other times I may misspeak and stuff like that can happen. So I only lightly edit these videos. So it's as if you're here with me, and away we go. So this is a fantastic looking radio. The condition of it is surprisingly good. It's from 1925. Let me see if I put a little more light on the front of it here. Look at the wood on that. Isn't that fantastic? It looks like it has depth to it. 1925, this of course has come out of a larger piece of furniture, if you like. The speaker has not come with it. The speaker is a horn speaker inside the cabinet, something I've never quite seen before. And this is a Magnavox radio type D. It's a TRF radio, a tuned radio frequency radio. It's the predecessor of the soon to take over super heterodyne style of radio. So this is very, very different from modern radios. I think this is probably a wonderful example. 1925 is very early. 1923 or so was when commercial radio manufacture began. You can go to a store and buy a complete radio. Before that, manufacturers made parts. People bought the parts and put them together as kits. Generally speaking, teenage boys were doing that back then. The big feature of this radio, and this was a sales feature of this radio, is this ganged capacitor, which today we don't think anything twice about a ganged capacitor. But before developing this method where you have one knob that turns 3 capacitors, you had 3 knobs turning 3 capacitors, maybe even 4. And it was a tough go to tune a radio properly and get it to receive. So as usual, as the years go by, maybe even the months go by, new technology is introduced, in particular the tubes. New tubes were being developed. These are all triodes except this guy. I just took a look at the schematic already. We'll look at it together in a minute or two once we look this over a little bit. This isn't the right tube for this radio. I'm pretty sure of that already. But when people have these old radios and they don't plan to play them, they can't stand having an empty socket, so they'll stick some old tube in. It could be the case of all these. All these may not actually belong to this radio. So the socket has come loose on this. It's just quite common, especially these have this pin. You need to put it in and turn it a bit. The socket makes contact not from sliding into a sleeve, which is a more modern being 1929, 1932. These came down onto a spring-loaded finger, I guess I could call it. And so because I had to push down, they had to lock in with these little pins, like a bayonet, like a bayonet bayonet connector. 450 is probably referring to the transconductance, although I don't know why they wrote that there. I see another one over here. So what I'm doing today, just to make it clear, I'm not going to try to play this, that's for sure. I'm going to examine it and get a feel for what's required. Sometimes these old radios, there's not much to them. Some coils, the odd capacitor, and there isn't a lot you can really do to them. So other than make sure the tubes are good and the like. This one appears to have lived a really good life because there's just nothing wrong with this cabinet. If it was refinished, and it may have been refinished at some point, somebody did a wonderful job on it. A real professional job on it. Just looking at the wood cabinet, you can't even see the seams in here. where these two pieces of wood come together. Really, really beautiful stuff. Some holes here, I think, for cables to go in and out. We've got speaker terminals here, if I can get them on camera. Kind of see them back here. And then there's a battery terminal here. Battery terminal here. That's quite the plug too. Looks like it has a key inside, so you're putting it in the right way. So this is going to be bringing up voltages from a set of batteries. Some high voltages and then some lower voltages to drive the heaters. So I imagine. If we just take a look at the front here, which is pretty interesting too. Get just a little bit more light on it. My light doesn't want to cooperate here. There we are. You can see Magnavox. It's surprising to me that Magnavox is an old name. I thought Magnavox was something out of the 60s or 70s or something like that. But no, Magnavox. So you can see the battery switch here, on and off. Pretty obvious what's that doing. In a lot of these radios, this switch will only turn off the power to the heaters of the tubes. When the tubes aren't heated, no current can flow through them. So the other batteries supplying the B plus or the high voltage to the tubes would only have a drain on it if you turn on the heaters and start the tube current flowing. So that part of it often is just left. And usually it's 95 volts or 90 volts, two 45 volt batteries in it. You see the volume control here. If you listen, you can tell that's a wire rheostat and the slider sliding over the wires. Sounds kind of scary, doesn't it? The volume controls were done in different ways in old radios. How it was done in this one, I'm not exactly sure, but again, we'll look at the schematic shortly and see. But one way is this could be right on the antenna, actually just depleting the antenna signal. Oh. Okay, I had to run out and answer my phone there. So we were looking at the dial here, I think. Let's take a look at it now. So you can see numbers around the outside going from 0 to 100. Maybe you can't see them, but they are there. And then inside are more numbers. 450, 460, I think that says. A little hard to read. Here I'm turning the knob and you can see what happens. And the little window slides. There you can see 500, 550. So these numbers are probably the wavelength, the number of meters of the wavelength. They don't match, what we commonly see today on AM radios. 530 kilocycles up to 1600 kilohertz, if you like. So that's probably what that is. I'm not sure why initially everybody wanted to talk about wavelength, but it may have had to do with the relationship with the antenna. So lower the wavelength, or the longer the wavelength, the longer the antenna. So maybe that communicated better to them what size antenna they needed on these things. So, oh, I think I just won something. What'd I win? Tell him what he's won. Okay, no, I didn't win anything. Okay, so the battery, volume, looked at the tuning, looked at the tuning system. What else is up here that we could take a look at? There are some interesting parts in here. Let me stand this right up like this. So we can see a tag here. I'll get my close-up camera. We'll actually read this in a moment. But the parts that are a little bit interesting. This resistor, wire-wound resistor here, and there's a capacitor here. This is a capacitor. You see the two plates on the outside and a material in between. Back at this time, they didn't really bother covering these things up. They're just kind of out there like that. The most interest is this resistor here. So this is removable. This is part of the detector in the radio. Resistance unit. Craven radio or something radio. The sign of merit, and sign is spelled S-I-N-E. Newark, I think it says Newark, where it was made. So these are removable because if you were receiving a strong station or a weak station, you might want to put in a different value of resistor in here. The thing about this, it's a high resistance, and making a high resistance was difficult. Manufacturing them was difficult. You can see what they ended up with, a glass tube, and sometimes inside here are carbonized paper and other methods for achieving a high resistance of maybe a megohm or somewhere in that range. Something like that. So, of course, that's the modern detector, the tube-based detector. Now let's look underneath. Let's see what we got here. It's just hard to believe this is from 1925, isn't it? Look at the condition, but it's been inside of a cabinet and it's been taken care of. So all screws are the same. Let's take them out. Probably going to find some coils under here and a lot of wiring. Times this has come off in the life of this radio. There's really like no user serviceable parts in here. Holy smokes, look at those. Wow, those are fantastic looking. Oh my gosh. Well, let's see. This looks like a more modern part that's been installed sometime in its life. These have numbers written on them, 70, 51, 51. Well, I gotta get my close-up camera going, but let's take the long shot first and just study it up. And we can see the volume control, and you can see there's a coil, if you like, and you can see how the slider slides on it there. Very good. Here's the on-off switch. Great big thing. And some spiders living in here. See this wire, the insulation is cracked off of it. But it looks different than all the other wires. These are all cloth covered, probably some kind of rubbery insulation underneath. These are quite the coils. They very, very carefully spaced the wires apart and then held them with a band out here and what looks like glue. Looks like a glue. This would be the manufacturing challenge, I would think, anyway, doing this. Some strings tied in here. Pretty sure I can see a coil inside this one. Maybe right up in here. There's something going on there. Just exactly what these black materials are, I don't know. Some kind of fibrous material, fiber board of some sort. You can see the bottom of the tube sockets now. And you see the spring-loaded fingers that the tube pushes up against. Pretty substantial. Very unreliable way of connecting tubes. Another capacitor sitting here. The wires are tied into bundles with string. It's done here too. No one's touched that. These two transformers are probably audio transformers, probably connecting one audio stage to the next, but not quite sure. Just what these coils are doing, I'm not quite sure either. Exactly what they're doing. These could be interstage coils of some sort. There doesn't seem to be anything that'll turn on them or rotate. Now I can see a coil inside this one. Hard to see, but it's in there. You can kind of see it on camera too. Kind of a white, it's got like a white wire in there. Why in these old radios, very often these coils are done with a green colored wire. And what kind of insulation is that? These are quite thin. I don't know. These two have a darker green color. This one's a lighter green color. So lighter green color, and this wire appears to be different than the rest. I wonder if this is a replacement. It's got the tie strings here. Why it would be a different color, I don't know. You can kind of see that on camera too. These guys present a lot of problems. Not only the sound quality through them is difficult, but there's often failures in these kinds of transformers in these older radios. Another capacitor right here. And it looks like the material in between has shrunk a bit because I can see a bit of an air gap in there. Probably not intentional. And I wonder what the value of something like that would be. I also kind of wonder how you can have these great big coils here and have them not interacting with each other. But obviously this is how they were made. In some radios you'll see where, you know, an antenna coil is positioned this way and then the oscillator coil is positioned this way. There's no oscillator in this radio. A radio like this, a TRF radio, is really a series of radios, one after the other. 2 or 3 of them, 2 or 3 radio or RF stages, each one independently tuned, although in this case it has a gained capacitor, so they're all getting tuned together. You can imagine how tricky that is. If what's going on is the capacitor here, each one of these is working against each one of these, and these are fixed, you'd expect some kind of trimming to be capable in here, some way of making a fine adjustment on these. There's a chance it's done by loosening off screws and actually rotating these relative to each other to compensate for variations in these coils. Or maybe they just did one heck of a job to make this stuff identical 3 times over. Would it be 3 times over? Well, we'll know when we look at the schematic. So if this tube, which I popped out earlier, I think I popped it out, if this is catching your eye as an unusual tube, it is a little bit unusual. This is a rectifier tube. I have one of these in my collection. And it's a cold cathode rectifier tube. There's no heater in here. What there is there's gas. Well, who knows if the gas is still in there. There's gas in here of some sort. Sometimes it's mercury gas. I don't see any loose mercury floating around. I doubt that's mercury. I don't know what gas is in there, but the gas enables the current flow, and it's just a rectifier. Raytheon BH, made in the USA. As I said, this. So often you'll hear this kind of sound coming from a tube like this. It's actually stuff that's down in the base here that's loose. Not right inside. It can be inside, but just because it makes that sound doesn't mean it's shot, but it's a little scary, isn't it? To put power on something like this, be the last time you power it up. Let's go over it with the close-up camera here. I say my objective today is to simply become familiar with the radio. Now, you know what we'll look at the schematic next, which I found on Radio Museum, of which I'm a member. Let's take a look at the schematic here. So this page is covering a number of schematics. The Model 1 dial, the Model A, and the Model D. What happened to B and C, we're not sure. 1 dial, I guess this was probably the first radio Magnavox made with one tuning knob. They were probably pretty excited about it, quite an achievement, as opposed to the older ones which have multiple tuning knobs. Very, very difficult to tune. So we'll come down here. This is the 1 dial. This is the Model A, the Model D. So you can see right away, Model A, Model D look pretty similar. All these old radios are quite similar. Very simple. Let's go through the Model D here. Not a very good print of it. So we have an antenna. This would be a long wire antenna hanging in the backyard type thing. You'd want a substantial antenna for these radios. Comes into a transformer. They've shown it as a step-up transformer. Now the signal's here. There's a capacitor, C number 1. So these must be the variable capacitors. I think they've drawn a little arrow here on the end of these 3 guys. So these are the 3 ganged, the gang of 3. The signal gets on the grid. You notice there's no cathode. It's straight off this heater. Of course, the radio is powered from batteries, so there's no chance of a 60 cycle, or at this time it would be a 25 cycle hum, if anything. They've labeled these wires, but I can't read the labeling. So it passes through this tube, gets amplified. A stronger signal goes through another step-up transformer. Capacitor. So I think probably when I was looking at the green coils, I'm seeing the green one is this big one, and then inside I could see a smaller one, a whitish one. It'd be this one. So this is not actually showing the ratio of the transformer. It's much greater because the white coil I saw inside was very small compared to the green coil. So multiplying the I'm not sure what to say here. Multiplying the voltage is not quite the right way to say it, but multiplying the signal strength, I guess I could say that. Probably 5 times, something in that sort. These tubes are probably identical. Radio frequency. What tube are they specifying here? So the resistor, the glass resistor, the grid leak resistor was 5 megohms. Very hard to make. Probably quite inconsistent when they made them too. You even have trouble measuring this kind of resistance in the whole shop. Volume control, 10 ohms. Fixed resistor, 1 ohm. 1 ohm. We'll find where that is. Toroidal coils. So the fancy thing we're seeing are toroids. Yeah, they're in a circular shape, like a donut. That's a toroid. Fuse. I didn't see the fuse. Half amp. Did not see the fuse. They're not telling us which tubes are in here. Not a lot of choice back at this time. There's basically, the way I understand it, there was always one outstanding tube. Last one designed and manufactured, and that's the tube that went into radios. They're all triodes. This would appear to be the same tube all the way through, even though this guy's doing audio stuff. It's not necessarily true, but it could be just the same tube, like a 226, which is really a 26. I don't think it's a 26th tube designed or put on the market. I don't think that's what the number means. I don't think it means much. I'm guessing. I don't know what tubes these are. We'll pull a couple out and see if there's some consistency. in them, or if somebody has just kind of randomly filled this guy with old tubes. It's really unfortunate. Did they name the tube up here? Why are they keeping it a secret? See, the guy who wrote this stuff out. This is handwritten, of course. You can tell, just hand printed. As he was printing this out, sitting probably in a darkly lit corner of a factory somewhere. Little did he know that we'd all be looking at it over the internet at this time, 100 years later. Little did he know. So this is the battery connection. We'll go back down to the radio we're looking at. A minus, B, A plus, B plus, B plus. This is B plus amp. Let's look. So you say B plus to the output, which goes to a speaker. Be a high impedance speaker, nothing like the kind we use today. Nothing like it. Probably 600 ohms or somewhere in that range. And then the voltage reaches the plate. And they haven't written the voltage here, but we can guess it's 90 volts. So that's to the amp. This is B plus to the detector, I think is what it's saying there. Come up. This is one of the iron core transformers we saw underneath. They're working at audio level. And I guess this capacitor is trying to chuck any RF that's made it this far. Get rid of it. Just audio from here through. Yeah, it's a good question as to whether these are actually functional anymore. So we follow the B plus on the blue wire. Of course, it goes to the plate. So what's with these guys getting their B plus? They also get it from the amp line. Why not just hook this one to the same wire? Why is it done like this? Separate. I don't know. Lots of stuff I don't know. You can't know everything. By the time you know everything, everything's a bore anyway. Here's the volume control. Now what's it doing? It looks like it's on the heater lines. These are the heater lines. A battery is the heater battery. What's going on with this? Don't know. Offhand. No big ground connection here. Earth connection. In North America, we use the word ground very loosely. Shame on us. In Britain, the word earth is used, and that clearly means something stuck in the earth. That's a much better term to use. Way to go, Britain. So we've got a large rheostat, and then it's controlling these two heaters. So you can turn these up full, get it more of a current flow through the tube, more amplification, I guess, and more volume out the front end. And I hadn't thought of other ways to do it. Like I say, some radios put a rheostat or a variable resistor right on the antenna. They just kill the antenna signal coming in. C1, C2, C3, C5, C6, C4. So the detector here, this technique was a big discovery in its day. Prior to this, there could have been other detectors, but one of them that survived for a while was called a coherer, as a very early day type detector you would never use in a radio, could not be used in a radio. So it's important that signal can be extracted, created from the antenna signal suitable to drive the speaker, because the signal on the antenna can't drive the speaker. Well, it can, but it would make the speaker do nothing, because of course it's a inappropriate frequency. It's way too high. So somehow you have to separate out the modulated part of the signal, and that's what goes on here. And the resistor is very important. It works in conjunction with this capacitor. Two of them combined control the bias on here, and have a way of, and I can't really explain it. I have to read up on it again to explain it well, so I won't try. But anybody can read up on this grid leak detector and find out a little more about how these work. I don't need to remind myself right now. I just know it's very important. This resistor is very important. Of course, the capacitor is too. They've labeled all these wires brown, gray, brown. It's the same color over and over. Gray. Gray is kind of the color of that coil. No, that's not making sense. Okay, anything more we can extract from here? Tell me what tube goes in this radio. What about the one way up here? They've constructed the tube diagram. It's not very pictorial in how the tube works, because we have the grid over here and the plate over here and the heater kind of sticking up towards the middle. Well, okay, one more quick flash through it. Is there anything interesting I missed? I don't think so. So the ground, let's follow this ground wire back. There's the fuse. The fuse is in the ground. So I'm picturing this as an actual earth, like a pipe or a rod shoved in the ground somewhere. When you're using a long wire antenna, the antenna will have a better time pushing through the radio if there's a ground on the far side, so to speak. I don't mean way over here, but down here. So I bet you if we follow this wire, we'll find out this is the one that has the ground on it. Yep. So basically the antenna is up in the sky, and off of here is a rod going in the earth. Between the two is a coil, and the signal is going through the coil, and you get the transformer action and so on. So operating this radio without grounding it, a little bit tricky to get a good signal. Today we could attach this to the hydro neutral, better yet, the ground prong in your house, but I wouldn't rush out and do that kind of thing. I'd be a little hesitant. It's not the best ground, but you know, we do have water pipes in our house. If you have a metal water service pipe, that's an excellent ground. Whoops. That's an excellent ground. It just might not be near where your radio is. Now, it's a little bit inconvenient to operate these old radios because you had to have the wire outside and you had to have this ground connection, so you had to put the radio somewhere where you could do that, you know, near a window or something of that sort. I don't think I can get any more out of this diagram at this point, anyway. I wish I could see what are those words. They didn't put them here. Well, I think that one's red. So I think they're just naming the colors here. That's yellow. That says yellow. Yellow, red, and something. Okay, let's go back to the radio. Okay, here we go. Let's start again with the front of the radio. I don't think we're going to find anything surprising here. Battery on, off. Nice arrow on the knob. Has the original knobs. Volume control, a little chip out of the... you know, a lot of this old stuff gets pretty brittle. And we have the tuning knob. Magnavox. So the idea of this was, you'd know your station is somewhere around 300 meters. So you tune it in. You get it tuned in, it's there. You look at the top scale and you read off, let me hold still a little bit here. You read off 33, you write that down in your book. You know, WKBW comes on 33. And then from then on you tune against the index dial, which goes up to 100, I'm pretty sure. And one of the things I kind of notice here is that there's no finger wear on this. So usually, you know, people are grabbing these knobs, dragging their fingers and their fingernails over the wood surface. And any well-used radio has signs of that kind of stuff. This looks just pristine. Well, I wouldn't be surprised if this has been refinished and someone's done just a wonderful job on it. Okay, let's take a look at this Magnavox radio type TRF, tuned radio frequency. I don't know why they say that. Was there another type floating around? I don't think Superhet was floating around yet. Well, there were some other ones. There was a Neodyme. I can't remember the name of them now. There were some other techniques, so maybe they wanted to distinguish by putting TRF there. Model D, number 3409. So we know they made 3,400 of these anyway. The Magnavox Company, Oakland, California. This must have been from Silicon Valley. It would be Glass Tube Valley. Oakland. Oakland's not near Silicon Valley, is it? Okay, so we'll look inside the top of the radio here, and we'll just start in the back corner. A lot of holding screws and that. Output. Those two terminals. Output. I'll grab my speaker, bring it in just so we can see it. There's a resistor, and no soldering happening here. It's all just mechanical pressure. And that's a pretty heavy duty wire there. Doesn't look like it's copper either. It looks like it's steel. I guess you'd want to use steel if you're trying to build up some resistance. Steel might be the way to do it. Is this a resistor or is this a coil? I think it's a resistor. You know what? It's in clips. Just pull this clip back and pop it out. But I won't pop it out. It's another part that's replaceable. And again, it's up on the top here where you can get at it, not on the bottom in the no user serviceable parts area. Let's just look at the top of this tube, and I can already see the number on it. This is UX226. Radiotron. Was it made by RVC? Not sure what that is. You can look right inside the tube. See, that's probably a mica disc. Piece of mica there, and then they have the support structures coming up from way down below, holding everything. And you can see the grid, you can see the heater. The heater looks just like in the diagram. The heater has to be held upwards. You can see a support rod coming over, a thin rod, and you can see a hook. It's actually hooked it, and almost certainly there's some spring tension in that, lifting up, because when you heat it up, and these get really hot. You have to heat these up almost like a light bulb to get the efficiency out of them. They hadn't learned about how to dope the heaters and eventually the cathodes, or coat them with special materials to achieve a higher electron flow. So they're just using probably tungsten. I don't really know what that is. But typically these glow almost like a light bulb, like an old style incandescent light bulb. And they're going to expand and contract, so you need a spring method of holding them up. You can start to see why there's only a life to these. They don't last forever. You see the top grid wire on this side appears to be, well, I can't see it right. Yeah, it's my imagination. I was going to say it seems to be drooping a bit. Now, these would be hand built to some degree, to a large degree. The blue light is just coming from a spotlight on my camera. That's what the blue color is. Okay, so 226. What about this one? This one looks the same. Where's the number? I'm sure it's the same. You can look inside. They have a look. It must be over this way. I'm having some trouble spotting it here. What's that say there? You know what the problem is? I've got my overhead light on. Just give me a second here. I'm going to switch it off. Nice big crack on something. We'll be talking about that in a moment, I'm sure. Let's see if I can get a better look at it now. Oh, we have another overhead light here that's causing trouble. There. Now we should be able to read it. Carton? Something on carton? Sorry for all the shaky camera work, but... Well, I'm just going to stop looking with the camera and look with my eyes and see what I can see here. You can ride around on the capacitor for a bit. Patented. You know, I can't even read it like this. Okay, don't worry about it. It might say the patent documents are on the carton of that the tube came in. Yeah, too bad we can't read it easily. Let's look at this one. 226. Did I get the number off this one? I didn't get the number in this one. Okay, coming out. It's coming out. What's happening is they're turning the writing around. You're supposed to look at this one way, and it should be right side up. You can see the camera. AAS asset assist. Fourth on carton. Insist. Insist on. That's what it must be. Insist. Insist. I don't know what that says. Well, you got me. We're down here. 226. That was easy. 550. Oh. It says 550, and then they wrote IG. Current on the grid? That doesn't make any sense. IG. Okay, that one's in. So that's a 226. They're all going to be 226s. And this last one. Looks like it's polished off the top. Let's take it out. Uh-oh, this looks a little different. This guy's got a sticker on it. Diamond Vacuum Products Company. A Diatron. A number 201. Okay, so it's an 01A. The 2 doesn't really count. 01A is a different tube. You can't see through this one. The whole inside is coated with what I imagine to be the getter material. But I have the feeling this is the wrong tube. Either maybe this is the right tube and all the rest are the wrong tube. keeping it secret. Okay. Come down and look at this resistor again. Sign of merit. But look at the way they wrote sign. Is that kind of a joke? Newark, New Jersey. A sign of merit. So people understood that these resistors were what made their radios sound good. So I think they were ready to roll out a lot of dough on a resistor here to make their radio sound good. Of course, it's the value of the resistor that's doing things. It's not how it's manufactured. You can look right inside and see. Like a metal collar there, and then some kind of material would look to me to be carbonized paper, and then another terminal, and then off to the very ends. I have about 10 of those kicking around. There's the capacitor. This is the one with a bit of a gap in it. Wait a minute. This is kind of odd. Maybe this isn't the way I thought it was. I gotta turn on my light again here. Sorry, just whacked the microphone. Wow, that's interesting. Now the wires are hooked up to this centerpiece. Exactly what's going on with this, I don't know. So the outside pieces are probably electrically involved, and they're grounded through the big metal plates that are sandwiching it, and then down onto the bottom here. If we looked underneath, we'd probably find wires coming off from under a nut under there. That's my guess. So maybe there's a very thin material. It does look like there could be paper on either side of the black stuff. The black stuff, really looks like rubber. You can see it does look like there's something like paper in there. That would be a typical material back in these days. Paper, oil, silk, various metals. Okay, let's take a look at the capacitor here. And it's made of what would be kind of a brass material, I guess, a brass alloy of some sort. And what I'm looking for is cracks. I don't think I'm going to find any. A lot of these radios of this vintage were made with pot metal. And pot metal is unstable, and it would crack. Today, you get an old radio like this, and this whole apparatus here made of pot metal, the frame and all that, all cracked and crumbling, falling apart. I think people who go much further than me in repairing these radios have methods to kind of rebuild all that. But wow, that's a big undertaking. This is quite a mechanical deal here. So all these things are screwed down. It's just been an assembly thing. Easier to make these parts and then screw them together in the factory than to weld them up, or any other method. Or this material is unsuitable for welding. Maybe it's an adjustment of some sort. I don't think so. Adjustments. If I were an adjustment, where would I be? I would be down in this area. It doesn't really look like it. Is that an adjustment? I don't think so. That square thing. Oh, maybe it is, because look at this one turned a little bit. Ah. So there's the adjustment, but good luck getting a tool in there. Maybe they're adjusted once in manufacture, or once the radio's built, that's the time to adjust this kind of stuff. So I'm going to guess that's an adjustment. Let's go around the other side and see what we got. Well, I don't know now, because the same thing's over here. Adjustment would be some kind of trimmer capacitor. That's not the easiest thing to make back at this time. So maybe it is some kind of one time in the assembly process, when they're building this component here, they do some kind of adjustment to it, because these are turned in different ways. And what else could they be in there for? And they sure look like you put a tool on them and give them a crank. that solder there was probably done with a huge soldering iron heated up in the flame of a torch and then brought over hot enough to apply the solder. Probably done in a fairly dark, poorly lit factory. Get down and take a look at the rheostat here. Feels quite nice actually. Like, it doesn't feel like it's pressing too hard or catching on the wires. The wires look to be in very good shape. These can easily be broken in a number of different ways. A little dark down there. Very good. Well, this is the connector for connecting the battery. So there'd be a big plug here, a bunch of wires coming out and going down to your battery sets. Battery is usually kept in a box. This is a fairly big unit. I think I have a picture I can show you what it looks like, a sales picture. So the batteries would almost certainly sit somewhere near the bottom. The battery that drives the heaters, the 6-volt battery, or maybe it's a 2-volt battery or whatever it was doing a lot of work heating up these tubes that was getting drained out. So periodically you'd have to charge it up. How are you going to do that? You got to run down to the radio shop and they'd exchange it for a charged up battery and give you and take your dead battery, and they would charge it somehow. Actually looking at an old article yesterday, and they were showing people who were putting up windmills to generate electricity to charge their batteries. Yeah, substantial windmills. Not a new idea. At this time, 1925, maybe not quite now, maybe a little earlier, all the delivery trucks in North America were electric. Can you believe that? That's where Elon Musk got all his ideas. Early electric delivery trucks. Pretty interesting. I wonder why they did that to the metal. Make it, maybe toughen it up. Make it more less likely to bend, because you certainly can't have any bends in any of these. They look just fine. Okay, now we're at the up to the tuning mechanism here, and this wheel. And the owner of this dropped it off with me. He's a bit of he's a friend. We stood and looked at it for just a little bit in my garage, and I made a quick assessment. And we picked up on this wheel. So this wheel is driven just by friction. We can't really see it, but way down below in here, when I turn the front knob, there's a wheel running on this. Essentially, this is a tire, a rubber band, and it's as hard as a rock. Really, if I hit it with something, it would shatter. You can see it's cracking all over the place, coming from shrinkage. The whole chunk ready to come out there, right in here. Big chunk like that comes out. Yeah, that crack goes right around. I wonder if that's come out and been glued back in by somebody. Let's just rotate it here and we'll look at it. There's another big chunk. Wow, if a chunk like that were missing, I think we'd have a hard time tuning this radio at all. Crack there, chipped all around the edges. Definitely a very fragile deal here. Now when I turn it, there's spots where the tuning kind of thumps in, and I'm sure there's a divot in the wheel at that point, like that. So, you know, you're not supposed to leave your needles sitting on your records, because the needle will put a divot into the record, and you're not supposed to. Lots of situations like that. Well, here's one. Somehow the shaft I'm turning presses up against this material, and if you leave it in one spot for, oh, I don't know, 50 years, that's what you get. It's not the end of the world, though, because we can turn this thing. So I guess the neat thing about it is when you reach the end of the road here, you can still turn the knob. It just skids because of the friction fitting, friction contact, whatever it's called, allows for that to happen. Otherwise, you could just drive this hard enough to break something. So something's got to give. I think that's kind of part of the magic of the doing it this method. There, it's going through. It's sticking now. Yeah. We're nowhere near done. There, I got it past. No. There it goes. Let's see. Let's bring that part up where it was doing that. There it is here. What was that sound? Oh, that's these banging at the end. So look at those divots. Got stuck in one of those ruts. So the ability of a radio like this to work today is surprisingly high. Because of the technique they use, the tuned radio frequency is just a radio, and another radio. It doesn't have the superhet technique of having a mixer tube, a local oscillator, all that stuff. Those radios, the superhet radios, they don't do well in noisy environments. Environments with all kinds of extraneous signals. And of course, back when this radio was alive and well, there wasn't much interference. The main interference were automobile ignition noises. Well, looks like we got to sort out the tube situation. Yeah, there's more written on this tube. Let's see what's written on here. Well, I can't read the sticker. So a lot of tubes had a sticker on them because the tubes were so unreliable. And you pay a lot of money, you go get a tube. Tubes didn't last long, so you're buying them. Buy the tube, bring it home, put it in. A day later, it's shot. Well, you go back to the dealer and go, "Hey, you sold me this tube yesterday." "I don't remember you. I don't remember you." So I'm never buying a tube from you again. And I'm telling all my friends, don't go buy tubes from that guy. So what sellers would do is they put a sticker on, and they'd write the date they sold the tube. Then when you came back after 2 months and said, "Hey, you told me this would last 6 months. I only got 2 months," he'd credit you some money on a replacement tube. That way you wouldn't run around telling all the neighborhood, "Don't buy tubes from that guy." It's interesting to think that in this day, at this time, this was real high technology. Very exciting. Revolution. You can hear people talking in your own home from far away and get music. Shocking. Why don't we get my horn speaker just to bring it in here? We'll take a look at that. Not that it's part of this radio, but it's part of that era. Oh, I had to back way up to make room for this. So it could be that this horn is a remake. It's not an original horn. It looks to me like it's made out of plastic or something like that. But this part is original. So this is the part we really want to look at. That's the actual speaker driver, if you like. Radiola loudspeaker. Radio Corporation, model number UZ1325. Radio Corporation of America, RCA. So I've never taken this off. I don't think I will now. But down in here, of course, is a diaphragm and what I imagine to be a coil. You can see that kind of terminals. It's exactly what would fit in this radio. Did I say I think these are 600 ohms? Not sure. So if we do get around to operating this radio, and it won't be soon, then this might be the speaker I'll use rather than have the speaker extracted from the cabinet. Oh, we want to take a look at the cabinet. Let me find that. I'll show you an image of it. So this image is coming from a radio museum. This is not exactly the same radio. It's just another somebody else's radio. Looks to be in pretty good shape here, and these numbers are a little brighter. The horn speaker is behind here, and the horn isn't as simply shaped as the one I just showed you. It's more complicated. There's funny curves in it and that in order to get it to fit here. And of course here's the radio. You can see how it slides out right here. And you would want it to slide out because you want to change the grid leak resistor once in a while. And that's it. That's what it looks like. It's fairly big. Okay, so that's the end of today's video. Thanks so much for watching it. Like I said, I'm not about to start work on this. What I'm actually going to bring in here is a dog I was working on some months ago, and I set it aside for a week. Now here we are months later. That's a like more 1940s type, 1950s type regular radio, and I can't get the two higher shortwave bands. I can't get the oscillator to oscillate, the local oscillator. So that's the challenge I want to work on for a couple of days anyway. We'll say farewell to this guy for a bit. So again, thanks a lot for watching, and see you on the next video.